Hello, welcome to section 7.3, and the topic for this section is assessing normality. Alright, why is this section important? So, generally a random variable is normally distributed provided the histogram of the data is symmetric and bell-shaped. And this works well for large data sets. Okay, but the shape of a histogram drawn from a small sample of observations does not always accurately represent the shape of the population. So if we have a histogram of data which is of a small sample size, the shape of the histogram may not clearly tell us that the sample or the random variable is coming from is normally distributed. So we need another way of assessing if that sample is normally distributed or that random variable is normally distributed. And therefore we turn to what we call the normal probability plot. Now in this class we will focus on how to use technology to generate that plot and also how to interpret the values that the plot gives us. Alright, so the normal probability plot is a scatter plot where on the x-axis you have the expected z-score, and then on the y-axis you have the expected z-score, and then on the x-axis you have the observed values. So whatever values you observed, whatever values are in the sample data, they will be on the x-axis. Then the expected z-score, which is calculated for you by software, comes out on the y-axis. So with a scatter plot, we can determine the normal if the plot falls on a line, creates a linear, a straight line. And if you remember what we did in chapter 4, we saw the linear correlation coefficient. So by creating this plot, the normal probability plot, we can also find the correlation coefficient from the plot. So whatever value the correlation coefficient gives you, we compare that value with the critical value, okay, that corresponds to the sample size you are looking at. So we have the rule that if the correlation coefficient, which we usually denote with R, if that correlation coefficient is greater than the critical value, then the sample data could have come from a normally distributed population, and therefore the sample data is normally distributed. Okay, so that is the conclusion generally. Yeah, so we are going to use this idea to answer the 4 questions that we are looking at in this section. Alright, so with the first question, it says determine whether the normal probability plot below indicates that the sample data could have come from a population that is normally distributed. And we have been given the plot, which is shown below, and the plot also, we also have information on the correlation coefficient, and that is 0.953, and the observed values, there are 25 observations, so the sample size is 25. Okay, so with information already on the correlation coefficient, then we need to find the critical value for 25 observations. And looking in the critical value table, which is also called table 6, the critical value for sample size of 25 is 0.959. So we compare 0.959 with the correlation coefficient, and we realize that the correlation coefficient is 0.953 is less than the critical value. Therefore, the relation in the plot is not linear. Okay, if the relation in the plot is not linear, then the sample data could not have come from a population that is normally distributed. Okay, so the result for question 1 is that this sample data we are looking at is most likely not from a population that is normally distributed. And if it is not from a population that is normally distributed, then the sample is not normally distributed. Okay. Then we move to question 2, which is similar to question 1. It says, determine whether the normal probability plots below indicate that the sample data could have come from a population that is normally distributed. So this plot has already been provided for us, and we have been given information on the correlation coefficient, which is 0.956, and the number of observations in this sample as well is 25. So when we compare the correlation coefficient 0.956 with the critical value for sample size of 25, which is 0.959, we also see that the correlation coefficient is less than the critical value. Therefore, the sample data could not have come from normally distributed population. Okay. On to the next question. Number 3. So suppose a sample of O-rings was obtained and the wall thickness in inches of each was recorded. Use a normal probability plot to assess whether the sample data could have come from a population that is normally distributed. So in this case, we have just been given the observations, and we are to find the normal probability plot, generate the plot, find the correlation coefficient, and use it to make our conclusion, to determine whether the sample data could have come from a population that is normally distributed. So you create a plot, right? You create the normal probability plot using a statistical software. In this case, I used StatCrunch, which I have demonstrated in another video. But when you use StatCrunch, the output that it gives you is the plot you see below. And that plot also comes with the correlation coefficient. So the correlation coefficient for this 16 data points is 0.997. So R is 0.997. Then we need to find the critical value from table 6. And for 16 observations, the critical value is 0.941. And when you compare 0.997 with 0.941, then the correlation coefficient is greater. And the conclusion will be that one can conclude that the data came from a normally distributed population. One can conclude that the data came from a normally distributed population. Okay, on to question 4. So question 4 also gives us just data sets, and then we need to find a probability plot. So the question reads, a random sample of 16 undergraduate students receiving student loans was obtained, and the amounts of their loans from the school year were recorded. Use a normal probability plot to assess whether the sample data could have come from a population that is normally distributed. So we have the observations, 9,100 up to 9,700, and there are 16 of these observations. So we need to create a normal probability plot. And again, I used StatCrunch to generate this plot. I demonstrated how to do this in another video, which you will see on Blackboard. So with the plot, we also have the correlation coefficient, which is 0.923. And we need to compare this value with the critical value for 16 observations. And that critical value is 0.941. So we notice that the correlation coefficient is less than the critical value. Therefore, the conclusion will be that the sample data could not have come from a normally distributed population. The sample data could not have come from a normally distributed population. So that is all for section 7.3. If you have any question, send me an email or meet me on WebEx. Thank you.